This is the second part of solving the science poorly answered questions quiz. Here, the poorly done questions. And we're gonna resume it, okay? So, we did from questions 1 all the way up to 20. So in this part, I will be revising question 20 and going forward to question 40. So let us just revise this question. Here, how can the density of an irregularly shaped pebble be determined? Let's see. Step 1, find the volume using water displacement. Now what is water displacement? It's when, let's say here, you have a graduated cylinder and it's filled, let's say, with 15. Let me make it bigger. Let's say here it's filled with 15 milliliters of water initially. So this is 15 milliliters. And now let's say after you drop the pebble, it went up to 20. So this is 20 milliliters. When after you dropped the pebble. So basically, water displacement, see here, the water level was here. Now the water level went up till here. So you see that space? This space is how much? How much water was displaced? Or how much water went up? And what is this? This is equal to the volume of irregularly shaped object. Okay, so basically what do? First, you need to know how much water was displaced. By doing what? You subtract the big number by the small number. So you do 20 minus 15, you get 5 milliliters. So how much water was displaced? 5 milliliters. So how much water was displaced is equal to the volume of the irregularly shaped object. So what's the volume of the pebble? Also 5 milliliters. Now guys, aside from this is an important note. You can measure the volumes for irregularly shaped objects. Irregularly shaped objects. I'm just going to write irregularly and irregularly shaped objects. Okay? For the regularly shaped objects, you can have like a cube. You can have a rectangular prism. Those two are examples, right? Irregularly shaped objects are objects with no shape. Okay? Such as a pebble, let's say. Now here, you use a ruler. So you use ruler. How? By measuring the 3 dimensions. The length, the width, the height. But for irregularly shaped objects, can you take the length and the width and the height? No, because it's irregular. So what do you use in irregularly shaped objects? You use water displacement, right? Or in other words, just use a graduated cylinder. Which looks like this here. And there are labeled numbers here. Okay? Now, how do you find the mass? Obviously, you find the mass using a balance. So, to find the mass, you use a balance. So, for mass, you use balance. And just here as extra, if you were interested, for the weight, you use spring scale. Okay? This is extra. Okay? Now here, how do you do the density? We say that the density equal to the mass over volume. So the over means divide. So how do you find the density? By dividing the mass by the volume. Okay? So basically this is what the question is about. So let's continue now. Here, the mass of an unknown substance is 9.0 grams and its volume is 10 centimeters cubed. The table below shows the density of different substances. What is the mentioned substance made of? Now guys, here we need to find the density. Okay, here we have a table of densities. When the density is 7.9, it's iron. If it's 0.90, it's logwood. And when it's 2.0, it's sulfur. So let's see here. First, you need to find the density that they gave you. So density equal to mass over volume. Here, the mass of an unknown substance. See, we're going to find out what it is from this table. So let's see. What's its mass? The mass is 9.0 grams. So what do you substitute the mass by? 9.0 grams over. Now, what's the volume? And its volume is 10 centimeters cubed. So what do you do here? 10 centimeters cubed. Now, instead of dividing it, what do you do? How to solve? I'm just going to write 9 over 10. You cross out the 0 and you move one step to the left. Why? Because instead of doing 9 over 10, 0 minus 0 is 9. 0.090. 10, you get 9 here. Instead of doing all of this, just do here 9 over 10, remove the 0, add the decimal point at the end, and move it one step to the left. So what do you get? 0.9 as a density. So now let's see. We got the density to be 0.9. What is this substance? This substance is logwood. Why? Because its density is 0.9. Okay, so how did we find it? We found the density using the mass and dividing it by the volume. You got 0.9. Obviously at the unit, 0.9 grams per centimeters cubed. So what is the mentioned substance made of? Logwood. So here. The property of attraction of different objects found at a certain distance from each other is known as gravity. Actually, just let me put in the answers, then I'm going to explain. Here. Basically here, they're saying the property of attraction of different objects found at a certain distance from each other is known as gravity. Why? Let's say here, you have this floor, okay? And you're standing up with, let's say, a ball in your hand, okay? What's gonna happen when you drop the ball? It's going to fall, right? Towards the center of the earth. So didn't you see? When you let it go, the ball didn't float. The ball didn't float, right? Here, it attracted to the floor. You can say that, attracted to floor. Right? Because when you let it go, it directly fell. It didn't even wait to fall. So, when you see the property of attraction of different objects found at a certain distance, what is this called? Gravity. So, when you see attraction, the answer will surely be gravity. Next, the SI standard unit of weight is, now here they want to confuse you between kg and Newton. So here they're basically confusing you between the mass and the weight. Okay? So what's the difference? The mass here, M for mass, M for matter. So mass is how much matter, and the weight is the pull of gravity. You can take this as a note if you guys want. Okay? What's the SI unit of mass? The SI unit, I'm just going to say SI units. There's kilograms, grams, right? Weight has one SI unit, which is what? The Newton. Capital N, because it's named after a scientist, Sir Isaac Newton. Okay? So here, they're asking you for what? The SI standard unit of weight. So let's go back to the table. The weight here, what's its SI unit? Newton. Okay? So let's move on. Okay, Chelsea is measuring the density of a block of modeling clay. She measures the mass of the clay block, which turned out to be 40.8 grams. She then measures the sides of the block, and the measurements were length 2.0 centimeters, width 3.0 centimeters, and height 4.0 centimeters. Chelsea then measures the sides. She then drops the clay block into a graduated cylinder filled with 30 milliliters of water. Okay, what is the volume of the block? And the reading on the graduated cylinder after Chelsea dropped it? And what is the density of the clay? So, let's write down all the information we have. She said that the mass is 40.8 grams. Now, its volume, do we know it yet? No, we don't. So let's see here. She then measures the sides of the block, and the measurements were, these were the measurements, okay? So, remember when I said 2 questions ago, I said that when you want to measure the volume of a regularly shaped object, regularly shaped object, you use a ruler. And what's a block? This would be the block. Okay? So what do you think she did here? She measured the length and the width and the height. Right? So now what do you have to do? You just have to multiply them. So length times width times height is equal to 2 times 3 times 4, which is equal to 24. So what's the volume? 24 centimeters cubed. Why? It's a regularly shaped object. It's just a normal block. So you can measure its dimensions, right? Length by the width by the height. Then what do? You multiply them and you get 24. Let's see. This one is actually important. So let's see it. The reading on the graduated cylinder after Chelsea dropped the clay block in. Okay. So initially it was filled with 30 milliliters. So it's 30 milliliters. And we found out the volume of the block to be 24 centimeters cubed. Now guys, centimeters cubed is the same thing as milliliters. So here it's the same. But just not to confuse you guys, I'm just going to replace the centimeters cubed with milliliters. Why? Because they're the same as each other. So here, we're going to rewrite centimeters cubed as milliliters. Okay? So, now here we're using liquid displacement method. So, let's see, the reading on the graduated cylinder after Chelsea dropped it. Do we know the reading? No. So the reading How did you get 24 milliliters? Minus 30 is 24. Now, how? Remember when I said that the water displacement method, you do the big number, which is what the reading was after object was dropped. Okay? So drop. Okay, so basically here, do we know what the reading was? No, it's what we're trying to find. So now you need to subtract it by 30 to get the volume, which was 24. What do? You bring 30 to the other side. So it was 30. It went up by 24. We get 54. Okay? And actually, let me give you an easier way. I'm just going to remove all this right now. So we got the volume to be 24 and the graduated cylinder is 54. Now guys, if you remember, I told you that here, how much water was displaced? Amount of water. Oh my goodness. Of water displaced is equal to the volume of the object. So once again here, I have this graduated cylinder filled with 30 milliliters, and now it went up to this reading, but we don't know what it is. Okay, so we're just gonna take it as question mark. So let's see here. Here's, let me add more. How much is this? This is how much the water went up, which is the amount of water displaced, right? How much water went up is the amount of water displaced. Didn't we say that it's equal to the volume of the object? We did. So this little thing right here should be 24 milliliters, right? So add the 30 original milliliters plus the extra that rose. What do you get? 54 milliliters. Here, once again, it's 30. And now here, it's unknown. So what did you do? How much water went up? 24. Because the amount of water displaced is equal to the volume of the object, which we already found. So now, add these two together to get this. You add them, you get 54. So this whole thing is 54. Okay? So now here, let's see. The density of the clay. So now we're going to write the formula for density. The density is equal to the mass over the volume. So now we're going to go back to the question. She measures the mass of the clay block, which turned out to be 40.8. So what's the mass here? 40.8 over. What's the volume of the block? Let's go back to the answer we got. We said that the volume is 24. Right? So over 24. What do you get here? It's the same thing as saying 408. 408 over, so it won't work here. So I'm going to do it here. 408 over 240. We're just going to divide each by 4. Actually, just do it by 2. Here you get here for you. It's just a moment. 2, 4 minus 4 is 0. 204 over, now this one is equal to 120. So 204 over 120, that's divided again by 2. Here, we're gonna get 102 over 60. Oh boy, divided again by 2. Sorry for the long division, by the way. Here, 51 over 30. And then divided by 3, you get here, minus 3, 17 over 10. Finally, here, 17 over 10 is the mass and the volume. Now all you need to do, cross the 0, put the decimal at the end and move it. So what do you get here? 1.7. So here, 1.7. By the way, guys, in the written part, don't forget to put the unit. So we found the volume to be 24. The reading, here it's 30 plus the 24, which is 54. And the density is 1.7. Let's see. The amount of blank that dissolves in a given amount of something is known as solubility. A solution in which the maximum amount of solute is dissolved. Okay, let's see this. Let's see here. The amount of blank that dissolves, in a given amount of blank, guys. Remember here, if you watch the first part, a solution is equal to a solute plus a solvent, right? What did we say the solute? The solute is the one that dissolves in the solvent. And here they gave us a hint, the amount of blank that dissolves. Okay? Ask yourself, what dissolves? The solute is the one that dissolves. So what do you expect here? Solute that dissolves in a given amount of solvent. Here. Okay? Because here, let's say we have a glass of water. Okay? This is the water. And here we have the salt. And then we put it in here. After a while, the salt will dissolve. So basically, this is solubility. It's the amount of solute that you can dissolve in a solvent. It's how much you can dissolve. Okay? A solution in which the maximum amount, let's just cross these out for now, of solute is dissolved at a given temperature, saturated solution. Why? Does it make sense to say a solution in which the maximum amount of solute is dissolved at a given temperature is known as a equal solution? No. A greater than solution? No. A less than solution? No. It is saturated. Saturated solution is the maximum amount of solute you can dissolve like this. For example, here I'm gonna have a small glass of water. Let's say in this one, I'm just gonna put 3 to have an extra in case anything happens. Let's say here you have 3 spoons of salt and you put the salt in. What will happen after some time? It dissolved. But let's say that you can do more than 3 spoons. Let's say here You do 4 spoons. 4 spoons of salt. After some time, it's going to dissolve. I'm just going to write dissolve like this. And then let's now add even more. Let's try now with 5. It's going to write here times 5. Okay. What happens here? After some time, it didn't dissolve. Why? Because you passed the maximum amount of solute, that to dissolve. So why didn't it dissolve with 5? It's because you passed the maximum amount of solute that you can dissolve. So what is the saturated amount here? 4. 4 is the maximum amount of sugar spoons you can dissolve in water. This is an example. Okay? So, what is the thing that dissolves? The solute. And what does a solute dissolve in? A solvent. A solution in which the maximum amount of solute is dissolved is a saturated solution. So once you see maximum amount of solute, it's saturated. Let's continue. Okay. Stainless steel is an iron-based alloy that is more expensive than other types of steel. It is used to prepare utensils such as pots. Okay. Steel, guys, is a type of alloy. And what's an alloy? We said an alloy is a metal solution. And did you guys know that steel is actually made of iron and carbon, but you don't see them? So here, what is meant by stainless steel being an alloy? What did we say an alloy is? A metal solution. Okay? So, what is meant by stainless steel being an alloy? It means it is a metal solution. Okay? Why is stainless steel used in cooking utensils? Now guys, here we're gonna go back. What is steel made of? Steel? Oh, here. What is meant by stainless steel being an alloy? It is a solution of metals. Okay. And why is stainless steel used in cooking utensils? Why? It's probably because it doesn't rust. Basically, steel is equal to the iron and the carbon. Right? You might say that iron rusts. Iron rusts. Right? But most probably once placed with carbon, it's going to improve the condition of the iron and it will not rust. Okay? Basically here, when we go back to question 1, think of it as like you do it to improve the metal. So let's say, okay, I have this metal. Okay, I don't want it to rust. So I'll add this substance. I don't want it to break. So I'll add this substance. I want it to be, let's say, flexible. Actually, no, that's unlikely, but okay. I'm gonna add that substance. Okay? So basically here, you're trying to improve the metal. So improve metal. So why do you think stainless steel is used in cooking utensils? Because it doesn't rust. Because once with carbon, it improved the iron and the steel so it doesn't rust. Okay? Also guys, look for the positive. because you always improve a metal. Here, it is very light. It doesn't make sense to say, oh yeah, this utensil is light, right? And you can't say it's flexible. Like, you're not gonna be eating with a flexible fork. You're never gonna get that food in your mouth. Let's be honest, you won't. Let's see. Match each mixture to its type. Okay, let's see what they have for us. Amazing. Let us start with the easiest one, which is steel. Now guys, what's steel? It's a metal solution. And what's a metal solution? A metal solution is an alloy, right? So which one says alloy? This one. Why? Because steel is a metal solution and metal solutions are called alloys. Next. Here, sugar and water is the second easiest one. Sugar and water. Sugar is a solute and water is a solvent. So, it's like a mathematical equation. A solute plus a solvent, what will it give us? Solution. Right? So, sugar and water is a solution. Why? Because it is composed of a solute and a solvent. Let's see next. Sand and water. Now guys, here, let's say you have this is water. Okay? And then you place the sand particles inside. Now guys, the sand is actually gonna settle to the bottom. So highlight the S here. Settle to the bottom. Until after some time, done, it fully settled in. It's now comfortable inside the water. So what is this called? When large particles settle, S for suspension. Okay, why? Because sand turned into a large particle and settled to the bottom of the liquid. Now, a colloid. I'm just going to use Why is cloud a colloid? Because when you wake up and you see, let's say here, a cloudy sky. Here. Did the cloud settle? No. But did it dissolve in the air? No, it didn't. So, it's when small particles do not settle. Because you're not gonna wake up and see the clouds on the ground. Yeah, no, that's not ever happening. So, yeah. So, why is cloud a colloid? Because the cloud particles, they do not settle down. Also, I like to think about it. C for cloud, C for colloid. Okay? Once again, sand in water, the sand settles, that's suspension. Steel is a metal solution, and a metal solution is an alloy. C for cloud, C for colloid. Sugar in water is just a basic solution. Okay? Guys, don't get confused. Don't put steel as a solution. It is a metal one. So for metal, it has its own category, which is an alloy. Okay? Let's see. Scientists identified more than 100 elements. Okay? This one is in the book, a bit of information in the book that's gonna come at a random time, okay? 500, too much. 240, also a lot. Those two are too much. Okay? Okay guys, I think they discovered 114 elements, probably. But yeah, I know that they discovered more than 100. Next, what is the smallest particle that has the properties of an element? Now guys, I don't know if you saw the previous part, but in the previous part, we discussed some meanings, but it's fine, I'm just gonna do it one more time. Compound, element, molecule. Once again, an atom is smallest particle, and what does it have? It has properties of its element. Yeah, that's what I mean. So what's an atom? An atom is the smallest particle that has the properties of its element. Now what's a compound? A compound is a pure substance with two or more, oh by the way, highlight this part, it's important. It's a pure substance with two or more elements. So when you see two or more elements and a pure substance, these two are for compound. Now, what's an element? I'm just going to write it up here actually. Substance that cannot be broken down any further. Right? And by the way, an element is a pure substance also. So when they ask you, what are pure substances? An element and a compound. Okay? For example, an element would be oxygen, carbon, those. Now what's a molecule? It's just two or more atoms joined by chemical bonds. Because I think they're going to ask you a question like, what are molecules joined by? What holds molecules together? Chemical bonds. And also they're going to ask you, I think, what holds compounds together? Fixed ratios. For example, when I say H2O, we have 2 hydrogen to 1 oxygen, right? I'm not going to say 8 hydrogen to 2 oxygen, right? This is wrong. So for compound, so atoms, smallest particle, properties of the element. A compound is a pure substance in fixed ratios that has 2 or more elements. An element is a substance that cannot be broken down any further. Ignore this. And a molecule is 2 or more atoms joined by chemical bonds. So let's see. The smallest particles that has the properties of an element, what did we say that is? That is an atom. It's called the atom. Okay, a mixture is made up of 2 or more substances mixed but not chemically combined. Okay guys, I want you to know this. It's not chemically bonded, okay? This is actually really important. They might trick you at some point. So a mixture is made up of 2 or more substances, easy. But it's not joined. Oh my goodness me. Here. Just gonna write down there. It is not joined by chemical bonds, okay? Let's see. Air. Oh, first guys, I said we're gonna discuss this in the previous part. We have 2 types of mixtures. One is homogeneous. Here. Homogeneous and heterogeneous. Okay? So basically, homo means one. So you only see one part. For example, in a solution, you only see the water or the solvent. In an alloy, you only see one metal. In the air, you only see, you'd see nothing for air. Heterogeneous, hetero means many. Okay? So you can see many different parts. Okay? And once again, mixtures are not chemically bonded. Now let's see here. I'm just gonna write HO or HE or whatever. Air. Can you see the nitrogen, the oxygen, the carbon dioxide? Can you see it with your own eyes? No, you cannot. So it's a homogeneous mixture. Steel. Steel is a metal solution. Can you see, oh yeah, I see the iron, I see the carbon, I see this, whatever? No, you only see the steel itself. So homogeneous. A whole grain bread. You can see the different parts. Here, natural. Okay, you can like see the different parts. For example, like I don't really know how to describe it to you guys, but like you're not just gonna see one color of like a whole grain bread, okay? Like you're obviously you might see different colored grains or whatever you can see. Just know that a whole grain of bread is a heterogeneous mixture. Yeah, a heterogeneous mixture, okay? And sand. Sand is also heterogeneous. Why? You can see, for example, if there are any insects in the sand, you can see any twigs in the sand, right? So, once again, air, can you see the different parts? No, homogeneous. Steel, can you see the iron and the carbon and everything? No. Whole grain bread, you can see the different parts of the bread, especially if you slice it open. So, also heterogeneous. Sand, you can see insects, twigs, whatever. So it's also heterogeneous. Let's see. Match each term to its definition. Let's see here. Okay. Let's see this. Here they're actually using the indirect meaning, but the easiest one would be compound. Why? Because here they use the direct meaning. A pure substance, yes. It's made of two or more elements, also yes. And it's combined in fixed amounts or fixed ratios, also clear. So a compound is obviously a pure substance made of two or more elements that are combined in fixed amounts or ratios. Okay? Now, an element. What's an element? It's a pure substance with identical atoms. Okay? Because let's say I have an example. Let's say a bar of gold, let's say. What am I even using? Okay. This is a bar of gold. Okay? And then let's say you have the gold atoms here. Every single gold atom will be identical. So every atom is identical. Or like the same. Just write is the same. It's easier. Because it's not like when you zoom into like a gold bar in a microscope, you're not gonna see that one different atom, right? It won't work out. Why? Because an element is a pure substance with identical atoms. All oxygen atoms are the same, all gold atoms are the same, all carbon atoms are the same. Now we go mixtures. What's a mixture? A combination of two or more substances, right? For example, I want to make a salad. I take the tomatoes, the lettuce, whatever you put, and then you put them together, right? So basically, it's just a combination, two or more substances, okay? So you can just take a look at it before I answer. So once again, mixture is a combination, so mixture combination of two or more substances. An element, pure substance, yes, with identical atoms. And a compound, once again, it's a pure substance made of two or more elements that are combined in fixed ratios or fixed amounts. Let's see question 31. Okay, once again, guys, I keep telling you, the substance that dissolves in a solvent to form a solution. So something plus solvent gives us a solution. What's missing? The solute. And once again, the solute is the one that dissolves. Okay? So, what is the substance that dissolves? It is the solute. Guys, don't put solvent, because does a solvent dissolve in a solvent? No. Okay? And an alloy is a metal solution, right? Is an alloy part of a solution? Just let me go back. Here. Can I say that an alloy, or like steel, let's take steel as an example. Can I say that steel plus water is a solution? This is absolutely wrong. It just doesn't make sense to say that, okay? So an alloy isn't part of a solution, and a solvent can't dissolve in another solvent because it's basically the same. So what is the substance that dissolves? That is gonna be the solute. So the solute dissolves in a solvent. Circle the separation technique used to separate substances in a liquid solution. Okay, I'm just gonna make a small summary for you guys for each one. Filtration is insoluble solid from liquid. What's an example? Sand in water. When do you use distillation? To separate substances in a liquid solution. Crystallization, you separate solution by removing solvent. So basically, in other words, salt in water also. Salt in pond, lake, ocean. And here you use salt in water. Salt in water. Or sugar in water. Oh my goodness. Sugar in water, okay? But what's the difference, guys? You might be confused. If you are confused, if not, that's actually amazing. Crystallization, you're removing the solvent. For example, there's a pond, okay? And then we're gonna let the water evaporate. And let's say maybe after a few days or weeks, you're gonna find a bit of salt coming out. Obviously, if it's a salt water pond, okay? You're gonna see a bit of salt popping out of the pond. Why? Because some of the water evaporated, So that means some of the salt won't be like dissolved anymore. It's gonna come out. Recrystallization, purifying substance. Again. So basically it's a repetition of crystallization. When you let all the salt show and almost all the water evaporated, if you want to recrystallize it, you can add in more water, okay? And then let the water evaporate again. Do it again. What are you doing in the meantime? You're purifying the substance again. Okay? Again and again. Selective solubility here, it's just separating two solids, such as white sand and salt. Like this is the main example, white sand and salt. So take a look at it. So once again, to separate, a separation technique used to separate substances in a liquid solution. Guys, when you see a liquid solution, okay, like this, it's gonna be distillation or simple distillation. What can be separated by distillation? Now, if you guys remembered in the previous question, we wrote that distillation, what can we do? Sugar in water, right? Sand in water. Oh, sorry. Salt in water, I mean. Just ignore what I wrote. Salt in water. Okay? Let's see, maybe there are more. Let's check it out here. Okay, let's discuss each one. Blood or food dyes, or like blood, food dyes, ink, those are all separated using paper chromatography. Smoke is, we said, a colloid, so it's heterogeneous. You can already see what it's made of, because for example, when you wake up in like a fire or something, you're gonna see smoke in the air. Like you can clearly see it, it's not dissolved in the air. So this is heterogeneous mixture. Heterogeneous mixture. So it's wrong. Water and salt, water and sugar, yes. Ink, we said, is also paper chromatography. And pebble and sand, guys, don't get confused, it's a heterogeneous mixture. Why? Because if I gave to you this bowl with these pebbles inside and this sand, you can just separate them normally, right? So this is wrong. Why? Also because distillation, it's a liquid what? A liquid solution. And solutions, we said, are homogeneous. So any heterogeneous option is immediately wrong. And ink and blood, we use them using paper chromatography. So what can be separated by distillation? Water and salt. This one. Water plus salt mixture. Let's see here. The crude oil components that can be separated using fractional distillation are shown in the diagram below. The component that does not boil and the component that has the lowest boiling point. Okay. Let me see. Okay, like this. Now, let's say here we're gonna do this. Here is the solution. In this case, the crude oil. So, its components, they're gonna go through here and enter the boiler. So this is the boiler. So after it, they're gonna go through here, and this thing, this whole entire piece of chunk of metal is a fractionating, oh, it's glitching here, fractionating column. And each of these exits, they have their own boiling points. For example, the highest boiling point could go here. The lowest boiling point, the mid boiling point, it's like not so high, not so low. It can go here, while the lowest boiling point exits through here. Let's say, as an example for you guys, let's say refinery gas boils at 20 degrees. It has the lowest boiling point. This is an example, by the way. It has the lowest boiling point, so it's the highest. Let's say that the naphtha boils at 40 degrees. It's higher than refinery gas, so it's lower. So guys, the lower it is, increasing boiling point. Okay? So let's say naphtha boils at 40, gasoline at 60, kerosene, let's say at 100, diesel maybe 150, lubricating oil, let's say 250, and heavy gas oil 300 degrees. Now actually 300 degrees is a high boiling point, so this is why it's the lowest. And right here, the little one that's being left out is the residue. The residue, it didn't even boil, so doesn't boil. Okay? So, did it even enter the fractionating column? No. Its route is different. It must have went through here, the asphalt, stopped, and then went down as residue. Okay? So you can just take a look at it if you need to. Okay, so let's see. The component that does not boil in the distillation unit. Now guys, the distillation unit is the same thing as fractionating column. Okay, so what doesn't even boil is gonna be the asphalt. Why? Remember I said its route should be different. It goes through here. Let's say it stops. It doesn't even boil. Why? It gets separated from the others and then directly goes down here as residue. As residue. So what doesn't boil in the distillation unit or the fractionating column? The residue. And what's the residue in this case? The asphalt. Here, which component has the lowest boiling point? We said that the higher the substance is, the lower the boiling point. So which one's at the tippy top? The refinery gas. Okay? If they ask you which one has the highest boiling point, heavy gas oil. So this is the highest. This is the lowest. And these are all, you can say, in between, so middle. Okay? So which one has the lowest boiling point? What is the one in the top? Refinery gas. Let's continue. Oh boy. Here. An apparatus to separate sand from seawater is shown in the figure below. What separation technique is used? what is the seawater after passing, what is the sand that remains, and okay, this is a bit long, but we're gonna go through it. Here, the separation technique is filtration. Why? You have so many hints here. Here you have, this is how I like to think about it, filtration. Pay attention to the first letter. Filtration has filter paper. This is our first hint. The funnel. And what else does it have? Now guys, here, the seawater that passes, it's called the filtrate, by the way. We're gonna discuss it later on in the question. So also F for filtrate. Did you notice? They all start with the same letter. Filtration, filter paper, funnel, and filtrate. So what separation technique is used? Filtration. Once again, what is the seawater passing and what is the sand that remains? Okay, once again, the seawater down there is called the filtrate. And the sand that remains, so sand remains, is the residue. Okay? So, once again, the seawater that passed is called the filtrate, and the sand that remains is called the residue. Oh yeah, guys, also, if you just need any trick, guys, if you remember in distillation, you don't need to follow it if you don't want to. Okay, I'm just giving you an idea if you want. In distillation, you know that the water that goes down is called water that goes down is called the distillate. So honestly, in filtration, it's not that different. Filtration, the water that goes down is called the filtrate. Okay, did you notice here? Distill, from the name distillation, and it ends with ATE. Also here, filter, from filtration, and it ends in AT and E. Okay? And the sand, actually no, it's fine. You don't need to know the second part. It's fine. The sand that remains, I'm going to write remains, is the residue. Also, the substance that doesn't boil from fractional distillation is also called the residue, right? So think about it as fractional distillation plus simple distillation, they formed filtration. Why? Because the sand has the same name as the substance that doesn't boil, and filtration, you pronounce it in a similar way, ends in ATE and gets its name from the separation technique. You can use this way if you want to. If not, it's fine. You can just memorize their names. So the seawater is the filtrate and the sand that remains is the residue. Okay? Now, what is required to separate salt from seawater? So in other words, salt plus water. Here you use two separation techniques. One is distillation, and two is crystallization. like this. So let's see which one is here. Filtration? No, it needs an insoluble solid from a liquid. Selective solubility? No, you need two solids, not paper chromatography. And not separation using a magnet because there's no metals. So which option is there? Crystallization. Crystallization. Okay, let's see. Consider the chemical reaction shown in the picture below. Identify the reactants and the products of the reaction. Okay, so guys, the reactants are the ones that participate in the reaction. So the reactants and the products. So the reactants are the ones that react, and the product is what is produced. So now we're gonna bring those together as a sentence. Okay? Oh my goodness, it's fine. Methane reacts, also reacts, with oxygen to produce carbon dioxide and water. So, what are the reactants? What reacts with what? Methane reacts with oxygen. So those two are the reactants. To produce, what does it produce? Product. So what does it produce? Water and carbon dioxide. Okay? So methane is a reactant. Why? Because it reacts with oxygen to produce, what does it produce? Water and carbon dioxide. Consider that the mass of methane is 16 grams and the mass of carbon dioxide and water produced is 80. So what is the mass of the oxygen consumed? Now, here we're applying the law of conservation of mass. So mass stays the same. Okay, so we have the methane, which is 16, plus the oxygen is equal to 80. In other words, we're saying that the mass of methane and oxygen is equal to the mass of carbon dioxide and water. Okay? Oh, by the way, guys, M isn't the symbol for methane. I just wrote M. Okay? So, here, 16 plus the oxygen, this is supposed to be the oxygen, gives us 80, which is the carbon dioxide and the water. So here, I'll just ask yourself 16 plus what gives 80? So 16 plus box equal 80. Bring 16 to the other side. 80 minus 16. You get 64. Okay? So what is the mass of the oxygen? 64. If you want to test it also, do what's 16 plus 64? 80. And 80 we said is the methane and the oxygen. It's equal to the mass of carbon dioxide and water. So oxygen is 64, which is correct because we have just proven it. When we said that 16 plus 64 is 80, so it's correct. So 64. Let's go. Question 37. A chemical reaction is often accompanied by an evidence that shows that a chemical change occurred. Okay. First, let's start with B. B is really easy. Which law states that matter matter, which is basically the mass, cannot be created nor destroyed. So in other words, mass stays the same. Right? So which law states that matter cannot be created nor destroyed? Which one? The law of conservation of mass, not law of division, because mass cannot be destroyed, and not the law of addition, because you can't create mass. So it's law of conservation. Mass is conserved. Okay? Now let's solve the following. Rusting. Iron would normally look so much more shiny. Here, let's say that this is the iron nail. It would normally look really shiny. Shiny and silver. Now it's red. I directly said it. Now, what color is it? It's reddish color. Reddish brown. So it changed from silver to the reddish brown. So guys, what changed? The color. So iron rusting has a color change. So you can just take a quick look. So iron rusting is color change. Why? Because it turns from the silver iron we all know into this reddish brown rusty iron. Now, here, explosion of fireworks. When you make your fireworks explode, what do you see in the picture also? Light. This is light. So which one makes sense? The production of light and heat. And guys, obviously fireworks, they're not cold, they're really hot. Okay, don't play with fire. Acetic, what? Let me see. Antacid mixed with vinegar. It's a production of a gas. Okay? Let me explain this one to you if it doesn't make sense. When you have production of gas, you know what happens? Bubbles. So bubbles form. So how do you know that a gas is being produced? When you see bubbles. And if you guys take a really close look here, what do you see? You see bubbles. Okay? So this is why it's the production of a gas, because you can clearly see the bubbles when they're mixed. Let's see question 38. Okay. Which component is always conserved during a chemical change? Now, it's actually the mass. Why? What is conserved? What stays the same? Mass stays same. Or the same, obviously. Mass stays the same. Right? Why? If you burn a paper, so here it's burning, obviously the temperature doesn't change. Now it's really hot. Okay? And now you have ashes plus the remnants of the paper. And if the paper here weighed 5 grams, the mass of the ashes and the remains of the paper will also be 5 grams. So what is conserved? The mass. Also guys, the state of matter doesn't make sense. State of matter is anyways a physical change, not chemical. So what always stays the same? What is always conserved during any change? The mass. The mass is conserved. Okay. When you dip a tea bag into a cup of water, the tea particles will slowly move out of the tea bag and spread into the water. What is the process by which the tea particles moved out of the tea bag? Here, first let's analyze the question. We have the word spread. Okay? Spread means diffusion. Okay? Normally, the first word, like the first thing that pops into my head when I say diffusion would probably be perfume in a classroom, right? Because let's say here this is the doorway, the door area of the classroom, and this zone right here is the back of the classroom. You sprayed a bottle of perfume here, okay? And the scent will be spreading out in the meantime, okay? Eventually, what's gonna happen? It's going to reach the back of the class. And after that, the full class will be smelling the scent. Why? Because the perfume spread. But this time it's just a tea bag spreading into a cup of water. Okay? So what is the process by which tea particles moved out? What did we say the process is? When the tea particles move out and spread, diffusion. So what's the answer here? Diffusion. Underline the state of matter that has the fastest rate of diffusion due to the fact that the particles have more space between each other. Okay, so here, so the particles have more space. So basically here they're just asking you which particles have the most space. It's gas, right? Because if you sprayed gas across the room, it's going to spread the fastest. It will directly occupy the volume of the room. Liquid, it will, but it's just going to take less time. So no, it's not the fastest. And solids, they don't spread because they have a fixed shape and fixed volume. So the answer here is gas. And the process is diffusion. So, last question. Okay, match each physical state to its descriptions. Now, a solid. When you have a solid cube, actually, it's fine. We're gonna do this orally. You have a solid cube. Let's see. Does a solid cube have a fixed volume? Yes, it does, right? Because it's not like when I drop like a block or like a marble into a box, will it turn into the size of the box? Like when I put a marble or a ball in the box, will it magically occupy the full space? No, right? Why? Because it has a fixed volume. Do solids change shape? Like if you put the marble inside the box, will it occupy the space of the box? Change into the box's shape? No, it won't. It has a fixed shape, right? So solids is fixed shape, fixed volume. This is why solids, they're really hard, okay? So both is fixed for a solid. Now gases, they both change. Okay, so and a liquid, it changes shape but has a fixed volume. Now, how would I think? Solid has fixed shape and fixed volume. Right? Gases have a changing shape. By the way, guys, if you want to not get confused in an exam, write it down this way. You'll see why. Changing shape, changing volume. So in gases, they both change. In solids, they're both fixed. Now comes the liquid. The liquid is in the middle. This is for a liquid. Okay? What am I even writing? Liquids. Okay? Did you notice here I wrote it in the order? Solids, we know, fixed shape, fixed volume. Gases, they have changing shape and changing volume. Liquid, it's right in between. So if you write it in this order, you will discover that the liquid, it will have the fixed volume and the changing shape. Why? For example, you have this jug of water and you filled it up to here. This is 100 milliliters. And then you put it all the way into this glass. See how it occupied the shape of the thin glass? But in the end, you're still gonna have 100 milliliters, right? It has a fixed volume, but it changes shape. Okay? So once again, solids have a fixed volume and a fixed shape. Gases have a changing shape and a changing volume. Liquids is in the middle, changing shape but fixed volume. Let's submit. Okay, and that's it. I wish you the best for your science finals.